The Orbital Commons, building the highways and habitats around Earth. Written and narrated by Isaac Arthur, NSS President. When we talk about the future of space, we often leap ahead in our imaginations toward gleaming colonies on Mars or solar-powered megastructures circling the Sun. I believe those days will come, but the real foundation of any spacefaring civilization isn't built on distant planets or exotic technologies. It's built right above our heads, within the orbital commons surrounding Earth. This region, spanning from low Earth orbit up to geostationary altitudes and even beyond a cislunar space and the Lagrange points, is already bustling with activity. Satellites zip past at thousands of kilometers per hour, space stations drift silently through the night sky, and with every launch we are adding more. But if humanity wants to become more than visitors in space, if we intend to live and thrive off Earth, we need to treat near-Earth space not as a place to pass through, but as a place to build. And that means infrastructure. Space is a harsh place to call home. Let's start with the basics. Space is not forgiving. It offers no breathable air, no natural gravity, no shielding from radiation. There ain't no such thing as a free lunch when it comes to getting around either, though it's easier to move around to a different orbit than to get into orbit. Getting into orbit is brutal. That's why most of what we launch into orbit today is highly specialized and self-contained, spacecraft built to do one job, with limited lifespans and little room for repair or expansion. But that model won't scale. If space has become a real frontier, not just for science or exploration, but for industry, trade, and even settlement, we need to build the orbital equivalent of roads, gas stations, warehouses, hospitals, and apartment complexes. We need the orbital commons. Defining the orbital commons. The term commons is an old one. It refers to shared spaces like pastures, ports, or highways that aren't owned by any one person or company, but are maintained for mutual benefit. In space, the orbital commons would include things like orbital fuel depots that let spacecraft refuel and extend their missions, tugboats and towcraft to move cargo and defunct satellites, construction yards where modules are assembled and repaired, radiation-shielded shelters and emergency medical facilities, habitats and dormitories for transient workers or long-term residents, traffic management systems that keep things from colliding. In other words, we're talking about the nuts and bolts of a living, working community and even an ecosystem in space. Orbital infrastructure. What comes first? The good news is we're already laying the groundwork. The International Space Station has taught us how to assemble, supply, and sustain large structures in orbit. Private companies are testing reusable spacecraft and propellant depots. NASA's Gateway and various commercial stations promise to expand our orbital footprint over the next decade. But if we want a real orbital commons, we have to think systematically. What comes first? What pays for itself? What unlocks the next level? Often, it starts with fuel. Launches from Earth are expensive in part because everything, including fuel, has to be lifted from the surface. But a network of orbital refueling stations, supplied either from Earth or from in-situ resources like lunar water, could change that. Imagine a cargo tug that lifts off from Earth, drops its payload in low orbit, then refuels and continues to geostationary orbit or lunar space. That simple shift could make missions far more flexible and cost-effective. Next comes mobility. Space tugs, autonomous vehicles that can reposition satellites or haul cargo between orbital altitudes, would act like the semi-trucks of space. They don't need to be fast, just reliable, reusable, and able to dock or grapple with various loads. Think of them as space equivalent of the tow truck and delivery van combined. Orbital tugs might also be able to bypass chemical fuels to make use of solar-powered ion drives or electrodynamic tethers, which need far less reaction mass, but are too low powered to climb out of an atmosphere and to the lowest orbit. After that, we start seeing orbital dry docks and construction yards. Not every satellite needs to be launched fully built. If we can assemble modular structures in orbit, from space hotels to power arrays, from zero-G manufacturing plants to deep space ships, we open the door to truly scalable development. living in the commons. Of course, you can't have a commons without people, and while robotic systems will always play a central role in orbital infrastructure, there will be increasing demand for human presence, especially for maintenance, oversight, and emergency response. That means habitats, not just large and possibly rotating stations providing spin gravity, but smaller modules too, for facilities that need to be separate from larger conglomeration but still need some for crew. But eventually we do see the rise of spin gravity habitats to allow long-term habitation by humans and flora and fauna in general. This is where we go from mission-driven spaceflight to infrastructure-driven civilization. Protecting the commons. But if we're going to build the commons, we also need to protect it. Space debris is already a growing hazard. Thousands of defunct satellites and rocket fragments zip around Earth at lethal speeds, and one collision can trigger a cascade of others, a scenario known as Kessler syndrome. That's why orbital cleanup services, real-time tracking, and active traffic management will be essential parts of the commons. So will legal frameworks. Right now, orbital space is governed by international treaties and patchwork national laws, but as more actors enter the game, private companies, space tourists, and even future space settlers, we will need clearer rules of the road. Who gets access, who pays for upkeep, who is responsible when things go wrong. Organizations like the National Space Society help lead those conversations, bringing together industry, government, and academia to craft policies that will help us climb into that future. We often say that space is the next frontier, but before we cross it, we need to build the bridge to it. We need to make orbit more than just a step in the launch profile. We need to make it a place where humanity lives, works, and prospers. Because the future of civilization may be written in the stars, but it will be built first in Earth orbit. And we hope you'll join us for helping make that future possible. Ad Astra.